Here's our last section on trig identities and unit circle extension. So first it says determine a formula for cosine of 4x in terms of cosine of x. So your formula sheet hopefully will have this identity on it, which relates cosine 2x to cosine, because it's asking us to find an expression for cosine 4x just made of cosine x. So the way you do that is you can build cosine of 4x. First you can say cosine of 4x is, I can make that into an expression that has cosine 2x's in it. You see how that works? So I took 4x, which is a double angle, and then I put 2x, which would be the single angle on the right side. I use this identity here. Okay? Now I'm going to further expand cosine of 2x by resubstituting this in again. So it's going to give me 2 times 2 cosine squared regular x, not 2x, minus 1 squared minus 1, right? So this is going to be, and I'm going to expand this now because maybe I want to simplify it. So it's going to be 2 cosine squared x squared minus 2 times 2 cosine squared x plus 1, and this is all in parentheses multiplied by 2, right? And then I subtract 1. So then I'm going to simplify again. I'm going to say, okay, this is 2 times 4 times cosine to the 4th x minus 2 times 2 times 2 cosine squared x plus 2. I distribute the 2, and then I have minus 1 here. Okay? We're getting very close to finishing. So this will be 8 cosine to the 4th x minus 2 times 2 times 2 is 8 cosine squared x. And then the last term would be 2 minus 1, which is plus 1. Okay? All right. Last of all, on this page, solve the equation sine 2x equals cosine x for negative this interval here. So I don't know what to do yet, but I do know that sine 2x has a formula. Sine 2x, if I look at my formula sheet, is equal to 2 sine x cosine x. So I'm going to put that on the left side, and then I have cosine x here. Okay? This looks suspicious. I'm going to subtract everything over to the left side and leave 0 on the right side. Okay? And then I'm going to factor out a cosine x. Okay, so I factored out the cosine x. So now I just say, okay, when does cosine x equal 0? When does 2 sine x minus 1 equal 0? Either one of those cases, they're going to multiply together and get 0. So actually, what makes cosine of x equal to 0? Well, when is the x-coordinate of the unit circle 0? That would be 90 degrees or negative 90 degrees. So the answers here would be x equals pi over 2 and negative pi over 2. Okay? What about 2 sine x minus 1 equals 0? When does that equal to 0? So we're going to add 1 to both sides. We're going to get 2 sine x is equal to 1. Then we're going to divide both sides by 2. We get sine of x equals 1/2. When is the y-coordinate of the unit circle equal to 1/2? That would be 30 degrees or 150 degrees. Okay, so that would be x equals pi over 6 or 5/6 pi. Okay, we're looking for radians here, right? Okay. We got these two solutions, or we got these two solutions. All right, last of all. Okay, we're looking at 5c. A cosine function is transformed into a function m of x. It is translated 2 units down. It is vertically stretched by a factor of 3. It is horizontally compressed by a factor of 2. Draw the graph of m of x and write down this equation. Okay, so we know that a regular cosine function looks like this. It starts at 1, goes through 0, then it goes through -1, then it goes through 0, and then it goes through 1 again. So this is the normal cosine function, the regular cosine function. Then we're going to translate cosine. First thing we're going to do is we're going to translate it 2 units down. So that means it's going to go 1, 2. It's going to be here, it's going to be here, and it's going to be here, here, here. And it's going to look kind of like this, centered at -2. Then we are going to vertically stretch it by a factor of 3. When we do that, okay, we're going to go from +1 down to -5. Okay, it's going to look like that blue one there. Then we're going to horizontally compress it by a factor of 2. So that means it's going to be twice as narrow. So this point is going to be here, this point is here, and this point is here, and this point is here. It's kind of like that. Okay, so this is m of x right there. And so it actually, repeats its cycle twice. Okay, then it says to use the graph of it. Oh, we still need to draw the equation. So the equation for this is going to be something like, it was multiplied, it was vertical stretched by a factor of 3, so the a is going to be 3. Then it's going to be cosine, right? Sine of cosine. And then the inside of cosine, you're going to have x, you're going to have 2x, okay, because it's horizontally compressed. And then we're going to we're going to subtract 2 from the whole thing, because we're going to move the center line down to y equals -2. Okay, so this is your function. Okay, all right. Last one. Use the graph of m of x to find what are the values of x shown on the graph which make m of x equal 1. So there's 3 values here. There's 1, 2, and 3 at least. Okay, and then we could also see them on the other side. Here, there's going to be probably here and here also, because it's just a repeating pattern. So some of the values that make m of x equal to 1 would be -2 pi, -pi, 0, pi, and 2 pi. Okay? And that's it. I think that's the last one, right? Yeah, it is.